April 1945. The ridgelines of Okinawa rose from the island's southern plain in a series of limestone escarpments that the Japanese military engineers who had fortified them had every reason to regard as natural anti-tank barriers of the most reliable kind. The terrain was not merely difficult for armored vehicles. It was by the conventional understanding of tank warfare that both sides had developed through 4 years of conflict across the Pacific's various theaters, effectively prohibitive. Gradients that exceeded the published climbing specifications of American medium tanks. Surfaces of exposed limestone and coral rock that offered tracks no reliable purchase. Narrow draws and ridgeline approaches that channeled any armored advance into kill zones pre-registered by Japanese anti-tank weapons positioned with the professional thoroughness of engineers who had spent months preparing exactly the kind of defense that the terrain made possible. The Japanese commanders who had designed the Shuri Line, the interlocking defensive network that anchored Japan's last major conventional defense of the Pacific War across Okinawa's southern ridges, had incorporated the terrain's anti-tank characteristics into their planning with the confidence of men who understood both the terrain and the weapon system it was supposed to defeat. They had not incorporated the ingenuity of the men who would be asked to take it. If you're watching this for the first time, subscribe and hit the bell. These are the stories that history almost forgot, and we find them every single week. The Sherman tank's presence on Okinawa was not, in its initial deployment, a surprise to Japanese planners. American armored units had accompanied Marine and Army assault forces across the Pacific Island campaigns since Tarawa, and Japanese defensive planning had incorporated the anti-tank mission as a standard component of island defense since the Marianas Campaign of 1944. What Japanese planners had incorporated into their calculations was the Sherman operating in the tactical environment for which tank doctrine had been developed, on relatively flat terrain, against defensive positions accessible to ground-level attack, in conditions where the tank's mobility could be applied within the parameters that its design specifications defined. The ridgelines of the Shuri Line were not that environment. They were the environment that the conventional analysis of tank employment identified as beyond the Sherman's practical operational boundary. The Japanese defensive planning that incorporated the terrain's anti-tank characteristics was not based on a misunderstanding of American tank capability. It was based on an entirely accurate understanding of what American tanks were supposed to be able to do. What it did not account for was what American tank crews, working with Marine and Army engineers, would actually do when the terrain that was supposed to stop them became the tactical problem that the mission required them to solve. The innovation that produced the spectacle of Sherman tanks on Okinawan ridgelines emerged from the same empirical process that had produced the bulldozer's tactical role, the skip bombing technique, and every other American tactical innovation of the Pacific War. From the observation of a problem, the identification of available resources that addressed it, and the organizational flexibility to deploy those resources in ways that doctrine had not anticipated. The specific problem was the Shuri Line's defensive positions, which had been engineered to resist direct infantry assault, and which required the direct fire support of tank, main guns to be reduced effectively, but which occupied terrain that the conventional employment of tanks could not reach. The solution was engineering, the systematic modification of the terrain itself, using the same engineering assets and the same organizational will that had put bulldozers against Japanese pillboxes on Iwo Jima, to create the access routes that the terrain had not provided and that Japanese defensive planning had assumed it never would. Marine and Army engineers working with tank crews on Okinawa developed, through the grinding trial and costly error of the Shuri Line's reduction, a set of techniques for creating armored access to terrain that conventional analysis had identified as impassable. The techniques were neither sophisticated nor elegant. They were the product of practical men confronting a specific obstacle with the tools available and the determination to find a solution regardless of what the technical specifications suggested about the obstacle's insurmountability. Cable systems rigged from the tank's own winches and anchored to terrain features above the ridgeline provided the mechanical assistance that the engine alone could not deliver against the steepest gradients. Engineer teams working under fire to cut footholds in limestone faces gave the tracks the purchase that the natural surface denied. In some documented instances on Okinawa and in the Philippines, tanks were literally pulled up ridgelines by cables attached to other vehicles on the reverse slope, a solution that no tank employment manual had described, and that the Japanese engineers who had calculated the terrain's gradient as an anti-tank barrier had not contemplated as a possibility. Because the possibility required a degree of improvisational determination that their model of American tactical behavior had not adequately predicted. The specific engagements that resulted from this engineering effort produced outcomes that Japanese defensive positions on the Shuri Line's ridgelines had been designed to prevent, and that their designers had believed the terrain guaranteed would not occur. A Sherman tank appearing at the crest of a ridgeline that Japanese anti-tank crews had positioned their weapons to cover from the front and the flanks, but not from above, because above was where no tank was supposed to be able to reach, arrived in a tactical geometry that the defensive planning had not addressed. The tank's main gun, firing from an elevation that the Japanese positions had not been designed to manage, could engage emplacements that had been positioned to maximize their protection against ground-level attack, and that the ridgeline's topography had placed in defilade against any weapon system that could not reach the ridgeline itself. The psychological effect on Japanese defenders who had organized their entire defensive calculation around the certainty that the terrain above them was a sanctuary from armor was documented in the same terms that this channel has encountered across every previous episode. The specific disorientation of watching a certainty dissolve in real time, of confronting evidence that a foundational assumption was wrong in the most immediate and consequential way that military experience provides. The Japanese anti-tank doctrine that had been developed for the Shuri Line's defense incorporated weapons and tactics that were against tanks operating within the terrain parameters that conventional employment defined, genuinely capable of inflicting serious losses on American armor. The Type 147mm anti-tank gun had demonstrated its effectiveness in earlier Pacific campaigns against Sherman tanks approaching across relatively accessible terrain. Suicide anti-tank teams, soldiers carrying explosive charges with the intention of placing them directly against tank hulls, had been employed with some tactical success in conditions where American infantry support was temporarily separated from its accompanying armor. Both approaches had been incorporated into the Shuri Line's defensive plan with the professional seriousness of commanders who understood that the battle for Okinawa was the last conventional defense available to Japan before the American advance reached the home islands themselves. What neither approach could fully address was a tank operating from above, from the ridgeline itself, firing down into positions that had been designed to resist attack from a direction that the terrain was supposed to have made impossible. The Type 1's effectiveness was predicated on engagement geometries that placed the gun and its target in roughly the same horizontal plane, where the weapon's ballistic characteristics could be applied against the tank's most vulnerable aspects. A Sherman on the ridgeline above a Type 1 position presented a targeting problem that the gun's emplacement had not been designed to address. The suicide anti-tank teams who had been trained and positioned to operate against tanks moving through the draws and approaches below the ridgeline had not been positioned or trained to operate against tanks that had reached the ridgeline itself, because the ridgeline had been the defensive boundary beyond which armored access was not supposed to be possible. The engineering effort that made the ridgeline accessible to American armor was not without cost. The men who cut footholds in limestone under fire, who rigged cable systems while Japanese defenders engaged them from positions above and below, who coordinated the pulling of tanks up slopes under the direct fire that the operation's noise and visibility made unavoidable, paid for the innovation in the currency that Pacific Island warfare had established as its standard exchange rate, in lives and wounds, in the specific physical and psychological cost of performing precise engineering work in conditions of sustained lethal danger. The casualty records of the engineer units that supported the Shuri Line's reduction document this cost with the statistical clarity of military record-keeping that assigns numbers to what the individual accounts describe in terms that numbers cannot fully accommodate. What those records also document is the outcome, The progressive reduction of defensive positions that Japanese commanders had designed to be permanent, conducted by American armor operating from terrain that the design had assumed was beyond its reach, producing by late May 1945 the collapse of the Shuri Line's coherent resistance and the beginning of the end of organized Japanese defense on Okinawa. The collapse was not solely the product of armor on ridgelines. It was the cumulative result of the same combined arms methodology. Infantry, armor, engineers, artillery, air support, naval gunfire, that American Pacific War doctrine had been refining since Guadalcanal and that the Okinawa campaign represented in its most fully developed expression. But the presence of armor on terrain that Japanese planning had designated as a natural anti-tank barrier contributed to that collapse in ways that the planning had not anticipated and that the defensive positions had not been designed to resist. The fuel that powered the Sherman's engine during the ridgeline operations, drawn from the same American logistical system whose depth this channel has documented across every previous episode, was the enabling condition that preceded every other element of the innovation. A tank without fuel does not reach the ridgeline regardless of the engineering ingenuity applied to getting it there. The American logistical system that delivered fuel to armored units operating in the specific conditions of the Shuri Line's reduction, conditions that included the disruption of normal supply routes by the same terrain that the tanks were attempting to cross, the pressure of sustained combat operations across the entire Okinawa front simultaneously, and the extraordinary demands on the fleet's replenishment capacity imposed by the kamikaze campaign, delivered that fuel with the reliability of a system that had been tested across 4 years of Pacific Island warfare, that had, in the course of that testing, developed the organizational resilience to sustain operations under conditions that would have disrupted a less deeply resourced logistical establishment. The tank on the mountain was, in this sense, the same argument that every previous episode of this channel has examined in its specific technological or tactical domain. The argument that a democratic civilization organized around the productive freedom of its citizens could generate, in the domain of military engineering and organizational innovation, a surplus of ingenuity and determination that resource-constrained adversaries could not match across the full breadth of the tactical problems that a global war generated. Japan could fortify a ridgeline. American engineers could build a road up it. Japan could position anti-tank weapons to cover the approaches. American tank crews could reach the ridgeline from above. Japan could calculate the gradient as prohibitive. American ingenuity could rig the cables that the gradient required. The calculation was always correct. The assumption that the calculation settled the question was always wrong. Freedom does not accept terrain as permanent. It looks at the ridgeline and asks not whether the gradient exceeds the specification, but what combination of cables and engineering and organizational determination would be required to exceed the specification. And then it assembles that combination and applies it to the problem until the problem is solved or the war is over. On Okinawa in April and May of 1945, the problem was solved first. And the Japanese commanders who had built their final conventional defense around the certainty that certain terrain was beyond the reach of American armor discovered, in the most immediate and consequential way available, that certainty built on the assumption of American limitation was the most fragile kind of certainty the Pacific War produced. If this story stayed with you, leave a like, share it with someone who loves history, and subscribe if you have not already. The engineers and the tank crews who pulled armor up those ridge lines deserve to be remembered with the precision their ingenuity earned. We will keep finding these stories,